All right, today we're tackling a really cool paper, and it helps answer a huge puzzle that affects pretty much everything, from your own electricity bill to big national energy policies. The puzzle is this: why do we so often get predictions about consumer behavior, well, wrong?
Okay, so it all boils down to a question that, on the surface, sounds super simple. How do we decide not just how much to consume, but what to own? Think about it. It's not just about how much electricity you use, but which appliances you decide to buy in the first place. And as we're about to see, the answer is, well, it's not simple at all. And getting it right, that has some massive implications.
At first glance, the answer seems obvious. It's like Econ 101, right? If electricity gets cheaper, we're going to use more of it. If you get a raise, you'll probably use more too. Seems pretty straightforward.
But what if it's not that simple? What if that really basic relationship is actually hiding a much more interesting story? What if that common sense view is actually leading us down the completely wrong path?
So here's the twist. Our electricity use depends entirely on the appliances we own. You don't just consume electricity out of thin air, right? You use it through things. And buying a big appliance, like an air conditioner or an electric heater, that changes everything. It's not just a one-time purchase, it's a commitment that can lock you into a certain pattern of energy use for years to come.
And this is exactly where that naive view falls apart. It assumes this straight line: higher income directly leads to higher electricity use. But the real view? It's way more nuanced. It sees that higher income first influences your choice to buy an appliance. That's a discrete yes or no choice. And then, only after you've made that purchase, does it lead to higher electricity consumption. That's a continuous choice of how much you flick the switch.
So this brings up a really thorny statistical problem called endogeneity. It sounds complicated, but the idea is simple. The decision to buy an appliance isn't some random event. The very things that make you decide to buy an air conditioner, like maybe you just can't stand the heat, or you live somewhere with brutal summers, those are the exact same things that are going to make you crank it up and use it a lot. The cause and effect are all tangled up.
And the authors of the paper we're looking at, Dubin and McFadden, they were so clear about this. They basically said that if you ignore this fact, your models will give you biased and inconsistent estimates. What does that mean in plain English? It means you're going to get the answer dead wrong when you try to figure out how much people will change their behavior when prices change.
Yep, this creates a classic selection bias. Think about it. The people who choose to buy an appliance are selecting themselves into a specific group, and that group is fundamentally different from the people who don't. The very act of choosing that appliance tells you something important about them, and it's something that also affects how they're going to use it. Okay, so we've got this big statistical mess. What do you even do? Well, in 1984, Jeffrey Dubin and Daniel McFadden came along with a brilliant solution, and it was so groundbreaking that it contributed to McFadden later winning the Nobel Prize in economics. What they did was kind of amazing. They basically integrated two totally different fields of study: discrete choice modeling, that's the stuff about choosing one thing over another, and continuous demand estimation, that's about deciding how much of something to use. They brought these two worlds together. And their method was just so elegant. It's basically a three-step dance. Step 1, you model that big discrete choice. Why did someone choose to get an air conditioner in the first place? Step 2, you model how much electricity they use, but, and this is the critical part, given the choice they already made. Then, step 3, this is where the magic really happens. You use what you learned from step 1 to fix or correct the bias you would have had in step 2.
So what they ended up with was this beautiful, coherent structural framework. For the first time, researchers had a solid way to look at a problem that had previously just stumped them. It gave them a way to handle both the what and the how much at the same time.
So, that's the theory, and it sounds great, but does it actually make a difference in the real world? Well, the proof, as they say, is in the numbers. Let's dig in and see why getting this structure right matters so much. Okay, take a look at these numbers. This table shows the price elasticity for people with electric heat. Now, price elasticity is just a fancy term for how sensitive people are to price changes. The old biased way of doing things, OLS, got a number of about -0.2. But when you use the corrected Dubin-McFadden method, that number jumps to over -0.25. That's a big difference. And look, this isn't just some academic detail. What this means is that consumers were actually way more responsive to electricity prices than anyone had thought. And that is a total game changer. If you're making policy about energy or climate, knowing the true number is absolutely crucial.
And the authors themselves put it perfectly. They wrote, "We therefore reject the null hypothesis that the unobserved factors influencing portfolio choice are independent of the unobserved factors influencing intensity of use." In other words, they proved, statistically, that the old idea that these two choices are separate was just plain wrong. They are fundamentally linked.
So in other words, the structure of the decision, it absolutely matters. You just can't ignore it.
Right. And the incredible thing is, the impact of this paper went way, way beyond just electricity. It created a whole framework for looking at these kinds of mixed decisions, and that left a huge, lasting legacy.
The Dubin-McFadden framework basically became the go-to template for all sorts of complex choices. Think about it. What car you buy, and then how much you drive it. Which health insurance you pick, and then how much medical care you use. Whether you decide to work, and then how many hours you put in. It's the same pattern over and over again.
This was a massive step forward for what's called structural econometrics. It allowed researchers to finally move past just looking at simple correlations and start building models that really got at the messy, complex, behavioral reality behind our choices.
So what's the key lesson here? It's pretty simple, but it's also really profound. If you want to get credible results, you have to model the decision-making process itself. You have to respect how people actually choose things.
And that kind of leaves us with a final question for you. What other choices in your own life are a mix of what and how much? You know, that big one-time choice followed by a bunch of smaller how much choices. Maybe it's buying a house and then deciding how much to spend on it, or choosing a streaming service and then deciding how many hours you'll actually watch. Once you start looking for it, you'll see this two-step dance, well, pretty much everywhere.